All right, let's talk about something that separates the good Go programs from the truly great production-ready Go programs. We're going to dive into how to handle shutdowns gracefully. This is one of those things that might seem small, but it makes all the difference in building robust applications.
So let me ask you a question. Think about an application you've written. What happens when it's forced to stop? I mean, what really happens when someone hits Control-C or when a system like Kubernetes decides it's time for your program to go? If you haven't planned for it, the answer is usually, well, it's not pretty.
You see, without a plan, you get chaos. We're talking about real consequences here. Connections just get dropped, leaving users hanging. You start leaking resources like database connections or open files, which can slowly bring your whole system to its knees. And the worst one? Data corruption. Anything that was in memory or halfway through a write operation could just disappear. It's messy, and honestly, it's kind of dangerous for your data.
Okay, so to avoid all that, we need to understand how the operating system talks to our programs. And it does that using something called an OS signal. The best way to think about it is like a gentle tap on the shoulder from the OS to get your program's attention.
So what is a signal, really? At its heart, it's just a simple notification. The operating system sends it to a process to say, hey, something's happened that you need to know about. For our purposes, that something is usually in order to shut down. Now, there are a bunch of signals, but you really only need to worry about two for the most part. First is SIGINT. This is the interrupt signal. It's the polite request you send when you hit Control-C in your terminal. But the really important one for production is SIGTERM. This is the terminate signal. It's the default for tools like Docker and Kubernetes when they tell your container it's time to stop. If you ignore this one, they'll get impatient and just kill your app forcefully.
So, knowing about these signals is the first step, but the real magic happens when you actually listen for that tap on the shoulder and then react to it. That's the whole idea behind a graceful shutdown.
And I absolutely love this analogy to explain the difference. Think of your app as a library. An ungraceful shutdown is like the librarian suddenly turning off all the lights and locking the doors. It's instant chaos. A graceful shutdown, though, is the complete opposite. It's an orderly, planned process where everything gets put back in its place before closing up for the night.
Yep, this is the digital equivalent of that chaos we talked about earlier. A total mess of trapped requests, half-finished work, and scattered data.
But this is what we're aiming for. It's the professional approach. We give our application a heads up so it has time to finish what it's doing, clean up after itself, and shut down properly. So much better, right? So how do we actually become that good librarian in Go? Well, the standard library gives us everything we need right in the os/signal package. Let's take a look at how to use it.
It really boils down to a simple 5-step recipe. First, you create a channel that can receive these OS signals. Second, you tell the signal package, hey, listen for these specific signals and send them to my channel. Third, you make your program wait until a signal actually arrives. Once it does, you run your cleanup code. And finally, you let the program exit. It's a really clean and effective pattern.
And here's what that looks like in the real world. This is a super common pattern for, say, a command line tool. The main part of the program starts up, does its thing, and then it just blocks. It sits there waiting for a signal. As soon as you hit Control-C, that block is released, it prints a message, runs any cleanup you've defined, and then exits cleanly.
Now, the absolute heart of this whole thing is this one function call, signal.Notify. This is the magic line. It's where you connect the OS signals you care about, like SIGINT and SIGTERM, directly to that Go channel you created. After this line runs, your application is officially listening for that tap on the shoulder.
Okay, so that blocking pattern is perfect for simple tools. But what about a long-running web server or a microservice? We can't just block the main Go routine forever, right? It has work to do. This is where we need to level up our approach.
This is really the key question that separates a simple script from a true production service. How do you handle shutdowns when your app is in the middle of serving requests and can't just pause and wait for the end? The modern, and I'd say idiomatic way to handle this in Go is with context. Since Go 1.16, we've had this amazing helper function called signal.NotifyContext. What it does is create a context that gets automatically canceled as soon as one of your specified signals comes in. It's a brilliant and clean way to tie signal handling into the rest of your concurrent program.
And look, this isn't just a nice to have. In a real production environment, this is absolutely critical. For systems like Docker and Kubernetes, properly handling SIGTERM is how you play by the rules and allow your containers to shut down cleanly.
In a microservices world, it prevents one messy shutdown from causing a domino effect of failures. And here's a pro tip for you. Always add a timeout to your cleanup logic. A shutdown that hangs forever is just as bad as no shutdown at all.
Whew, okay, we've covered a lot of ground here, from OS theory all the way to production-grade code. Let's just quickly boil it all down to the most important things you need to remember.
Here's your cheat sheet. Number 1, always handle SIGINT and especially SIGTERM. If you're building a simple tool, blocking on a channel is totally fine. But for anything more complex, like a server, you're going to want to use signal.NotifyContext. It's just the modern, cleaner way. Remember why we're doing this? To prevent data corruption and resource leaks. And finally, don't forget that timeout on your cleanup.
So I'm going to leave you with this to think about for your own projects. Your application might be running perfectly right now, but can it stop? Can it stop cleanly and professionally? When the operating system gives your app that tap on the shoulder, what's it going to do? Now you know how to make sure it does the right thing.